Hi everyone, I am Dr. Surjit Singh. Today we'll talk about the Leetcode problem, first and last position of an element in a sorted array. Let us begin. We are given a sorted array. We are to find first and last positions of an element in the array. In a sorted array, the best way is to use binary search to find the position of an element. We are given a sorted list named nums. We need to find the starting and ending positions of a target whose value is given as 4. We will first find lower bound of 4 in the list, for which we call the function findBound. Third parameter of the function is a Boolean variable first occurrence. We set first occurrence as true to find the lower bound and false to find the upper bound. In the beginning, our range of search window is the entire list. We run a loop while begin is less than or equal to end and find the mid position of the range. The number at mid is less than target, so we move begin to mid plus 1. In next iteration of the while loop, we find the new mid position. The number at the new mid position is neither less than nor greater than the target, so it is equal to the target. As the Boolean variable is true, we have to find the first occurrence of 4, for which one of the two requirements is that either mid is equal to begin or num at mid minus 1 is less than the target. As neither of these two conditions is true, we move the search range left by moving end to mid minus 1. In the next iteration, mid becomes 5. Its value is 3, which is less than target, and we increase begin to mid plus 1. In the next iteration, mid becomes 6. Now that value at mid is equal to target and mid is equal to begin, we return mid and save it as lower bound. There can be a list in which target is not present. In this case, fruitless iterations go on till begin becomes greater than end and the loop terminates without a return statement. In this situation, we return minus 1 as the lower bound. In such a case, upper bound will also turn out to be minus 1. So we do not have to proceed further to determine the upper bound and return minus 1 as the indices for both the boundaries. When target is present, after finding lower bound position, we find upper bound of the target, for which we call the same function again with first occurrence as false this time. First two iterations are exactly same. However, because first occurrence is false this time, we go to the else part to look for the upper bound. Neither mid is equal to end nor value at mid plus 1 is greater than target, so we move begin to mid plus 1, which also becomes the new mid in the next iteration. One more iteration gives this. Now that mid is equal to end, we return its value and save it as upper bound. Final result is a list containing lower and upper bound positions. Time complexity is of the order of log of n in a binary search. Space complexity is constant as only a few constant number of parameters are used independent of n. I hope you enjoyed the video. Thank you for your time. Please stay tuned for more such interesting videos.